How do exponents help with scientific notation? Imagine trying to write out a number like 1 followed by 25 zeros. It would take forever and be easy to make mistakes. That's where exponents come in. They help us write very big or very small numbers quickly and clearly. Scientific notation is a way to do just that. It writes numbers as a decimal between 1 and 10, multiplied by 10 raised to an exponent. The exponent tells us how many places to move the decimal point. For example, the number 100,000 is written as 1 times 10 to the power of 5. The 5 shows that the decimal moves 5 places to the right. Exponents are key because they make these numbers easier to handle. Instead of writing out all those zeros, we just write the base number and the exponent. If you have a tiny number like 0.00005, you can write it as 5 times 10 to the negative 4th power. The negative sign shows the decimal moves to the left. This way, scientists and engineers can see at a glance how big or small a number is. When multiplying numbers in scientific notation, exponents make the job simple. You multiply the decimal parts and add the exponents. For example, if you multiply 3.5 times 10 to the power of 4 by 2.1 times 10 to the power of negative 3, you multiply 3.5 and 2.1 to get 7.35. Then you add 4 and negative 3 to get 1. The answer is 7.35 times 10 to the power of 1. That's much easier than multiplying the full numbers directly. Dividing in scientific notation also becomes straightforward. You divide the decimal parts and subtract the exponents. If you divide 6.2 times 10 to the power of 5 by 2.0 times 10 to the power of 2, you get 3.1 when you divide 6.2 by 2. Then you subtract 2 from 5 to get 3. The result is 3.1 times 10 to the power of 3. Adding or subtracting numbers in scientific notation requires the exponents to match. If they don't, you need to shift the decimal of one number to match the other's exponent. For example, if you want to add 2.5 times 10 to the power of 3 and 1.2 times 10 to the power of 4, you adjust the smaller number to have the same exponent. You can rewrite 2.5 times 10 to the power of 3 as 0.25 times 10 to the power of 4. Now both have the same exponent, and you can add the decimal parts. The sum is 1.45 times 10 to the power of 4. Exponents also show us the scale of a number. A large positive exponent indicates a very big number, like the distance from Earth to the Sun, which is about 1.5 times 10 to the power of 11 meters. A negative exponent shows a tiny number, like the size of a virus, which can be around 2 times 10 to the negative 7th meters. This clear separation of size and detail helps scientists communicate and understand measurements precisely. In many fields like physics, chemistry, and astronomy, scientists work with enormous or tiny quantities. Exponents in scientific notation make these numbers manageable. Instead of writing out millions or microscopic fractions, they use powers of 10. This makes calculations faster and reduces errors. For example, the number of atoms in a single drop of water is roughly 10 to the 25th. Using scientific notation makes it easier to see and work with such huge numbers. In summary, exponents are the backbone of scientific notation. They allow us to write, understand, and manipulate very large or very small numbers efficiently. They show the size and scale of numbers at a glance and make calculations much simpler. Without exponents, working with the vast range of numbers in science would be much more complicated. They help us see the relationships between numbers and their meanings, making the world of numbers clearer and more accessible.